Welcome. This morning I have another algebra tutorial for you from Northfield School of the Liberal Arts in Wichita, Kansas. And this is the second part of a two-part video. The first one was solving a rational expression. And you might want to view that one first so that you can see both the similarities and differences between solving a rational equation and simplifying a rational expression. The basic steps we're going to go through are factor all denominators, and my tip on this is do this step when you're rewriting the problem. Then we're going to find the LCM, and then here's the distinct part that's unique to the solving of equations. Multiply each numerator by the missing factors, and I will tell you what I mean by missing factor when we get to that step. And note well that at this point, all the denominators will magically disappear, and then you can solve the problem as normal. Now, of course, there's no magic in algebra. There is something going on behind the scenes, and so when I work the problem, I'm going to show you what's going on behind the scenes. When we get to step 3, what's going on behind the scenes is we're multiplying each term by the LCM and then reducing each term by canceling like terms. The effect will be to get rid of the denominators. So let me show you the full process and then show you where I think you could skip some steps as long as you understand what's going on behind the scenes. So the first thing I'm going to do is I'm going to rewrite the problem, and when I rewrite it, I am going to factor my denominators. The first one doesn't need to be factored, but I'm going to give it lots of space for some work I'm going to do later. This is a square minus a square, so the difference of squares. So it leaves me with 3x plus 2, 3x minus 2, and this is equal to 3. And I'm going to factor by GCF. So I'm going to pull out a 4, and I'm left with 3x minus 2. Right? So I've factored all of my denominators, and now it's time for me to find the LCM. The LCM is all of my unique factors: 4, 3x minus 2, 3x plus 2. Now, my goal, and I see I've gone off page a little bit, my goal when working with an equation that has expressions in the denominator is I want to get rid of all of those, those fractional forms. I want to get rid of the denominators. But I still have to follow my rules of algebra. And I know that with algebra, I've got to keep this equation balanced. And I do that by doing the same thing to both sides. So what I'm going to do is I'm going to multiply both sides by the LCM. The other thing I need to keep in mind is that when I multiply this side by the LCM, I'm going to have to distribute it. So a simplified step that we do here is that if you multiply every term by the LCM, you have both done the same thing to both sides, and you've distributed where necessary. So I'm going to multiply every term by the LCM. So every term is going to get multiplied in the numerator, the LCM. So I followed all of the rules. Same thing to both sides, distribute where necessary. Then I'm going to simplify each term by canceling. I'm going to reduce by canceling like terms. These both have a 3x plus 2. These both have a 3x plus 2 and a 3x minus 2. These both have a 4 and a 3x minus 2. Notice that my denominators have all disappeared. They've all been canceled out. So I'm going to rewrite my numerators. And actually I want to keep my colors going. Here I'm just left with the 4. And on my last term, left with 3x plus 2. And then I can solve as normal. So negative 2 times 4 is a negative 8. So I'm going to distribute my negative 8 and get negative 24x plus 16. Plus, I'm distributing my 4x plus 4. That's all going to be equal to 9x plus 6. Continue to combine like terms and simplify, and on the left I'll get a negative 20x plus 12 equals to 9x plus 6. That will end up giving me a 6 equals 29x. And if I divide both sides by 29, I will get x equals 6/29. So I have solved this equation. And just to review the steps, I factored all of my denominators when I wrote the problem down. I found the LCM. Then I multiplied each term by the LCM. I reduced where I could, and then I was ready to solve as normal. Now here's what I want you to see. Notice that after I canceled out, look what factors remain. Not only did the denominators go away, but certain factors remained. These are what I'm calling the missing factors. And so instead of doing steps A and B, if we simply multiplied the numerator, each numerator, by the missing factors, we could go from this step to this step without doing parts A and B. Here's what I mean. So in this first term, if I know my LCM is 4 times 3x minus 2 times 3x plus 2, I look at this and say, okay, this has a 3x plus 2, so these are my missing terms. So I'm going to multiply my numerator by my missing terms. In the second term, I've got the two binomials, so I have those. What's missing is the 4. And in my final term, I had the 4, and I had the 3x minus 2, and so it was the 3x plus 2 that was missing. So I can go, if you ignore all of the red, I can go from this step to this step by simply multiplying each term by the missing factors and knowing that the denominators magically disappear. That saves a lot of writing, a lot of canceling, and simplifies the process. And so this is the process that I would have you go through. Again, factor all denominators, find the LCM, multiply each numerator by the missing factors, and then the denominators disappear and you can just solve as normal. Well, I hope this video has been helpful. Have a good day.